Welcome to the introduction video of TransAT. TransAT is a computational fluid dynamics software, and the acronym stands for Transport Analysis Phenomenon Tool. TransAT is a very versatile software with a focus in multiphase fluid dynamics. Therefore, it's given the acronym or category of CMFD, Computational Multiphase Fluid Dynamics. It's particularly suitable for complex physics, including turbulence, compressibility, phase change, radiation, and many more models. What makes TransAT especially unique is that it's programmed with a parallel implementation using MPI protocol. This means that simulations can be run on multiple processors of a computer. A multitude of technologies have been implemented to make TransAT what it is today. The base of TransAT is a finite volume-based solver. For the mesh, an immersed surface technique is used, which means that our objects are embedded into the mesh. There is turbulence, which can be used either with basic or advanced models such as RANS, LES, DES, and VLES, which can be used with all sorts of wall treatments. There's the possibility to solve for incompressible and compressible formulations, and rigid body motion allows the user to either specify motion for objects or couple the motion with the flow of the fluid. The following unique selling points exist for TransAT. First and foremost, the focus is on multiphase simulations, especially in energy and processes. Multiphase refers to multiple fluids regardless of their states. The application programming interface allows TransAT to be used in other services, and one of the most important features is the UDF structure, or user-defined functions, where through C++ programming, users can add or modify the solver, models, and post-processing of TransAT. Parametric studies makes it possible to automatically set up and run a parameterization. And TransAT has been coupled with various tools such as 1D solvers like Olga. TransAT is key for high-performance computing and is accessible through cloud services. TransAT is applicable in many areas and has been used in consulting projects or directly by clients in many topics. This includes energy, such as power generation, or in industry and processes in paper production or chemical refinements, mixing processes, oil and gas extraction, for mining or production of metals. Additionally, in infrastructure, TransAT could be used for simulations to predict ventilation or wind around structures, in wastewater treatment, or water supply and hydraulics engineering. The TransAT UI is simple and intuitive, well suited for either beginners to CFD, while still providing all of the advanced inputs for experts in CFD. Files provide for functions in saving and loading projects. The Geometry tab can create geometries or objects to put into the mesh. Mesh and BCs defines the basic domain. The domain is set up with the Mesh tab, and BCs are used to set up boundary conditions. The Input tab is used to control the models and other equations, and the Execute tab runs and controls the simulation. Here is an overview of the three most important tabs in the user interface. The first in the upper left is the Meshing tab, where you can see an object has been placed into the mesh and the size and shape of the domain is being set. Afterwards, the boundary conditions could be added. The second tab shows models. This is where the physical models such as equations, turbulence, multiphase flow are added. Additionally, phase properties are defined, simulation parameters, and output management. In the third tab below, execution, we see running of a simulation where residuals are plotted to a graph as well as the value is output to the text below. In the left side of the execution window, we have a unique feature called SimInfo, which shows all of the relevant simulation information. The meshing in TransAT is very important for setting up a reliable model. The workflow of meshing consists first of, if necessary, importing a CAD file for an object. The object must be in STL formats, and the object can either represent the flow domain or it can be an abstraction of the flow. TransAT can be used to create simple geometries. However, more complex things are better imported from another STL file. It can be loaded into the 3D Cartesian grid and automatically refined near the walls. Then sub-blocks are created, which either change the shape of the domain and or set up the simulation for parallel processing. The advantages for the applied engineering in the block meshing is that it is fast and intuitive. As seen in the image to the lower right, the blocks have been automatically subdivided around the necessary geometry. This is also suitable for conjugate heat transfer, porous media, and rigid body motion, where object motion is either specified or coupled with the fluid flow. While meshing is one important step in setting up a simulation, the overall workflow looks like the following. First, if needed, an object should be created. This should usually be created in an external software dedicated to CAD. This could be Rhinoceros, FreeCAD, SolidWorks, or any other software that can create the object as an STL format. Once the STL is valid and closed, it can be imported into TransAT, where the rest of the simulation can be set up, including providing the domain and mesh, the boundary conditions, equations and models, and finally, executing the simulation. After some time that the simulation is executed, results will be available for viewing. This can be output either to ParaView, an open source software, or TechPlot, another post-processing software. Finally, let's highlight some important aspects to keep in mind while using TransAT. If using TransAT on Windows, it can be opened with the desktop icon. Otherwise, on Linux, it should be launched with the command transatui.py. Once opened, you can either create a project or open an existing project. It's very important that each project is saved in its own folder without any other project files in the same folder. You could have a sub-project as its own folder inside another project folder, but it's important to keep STT, INP, and other TransAT-related files separate from other projects. We wish you good luck in setting up and running simulations. If there are any problems, please contact our team.